Hi everyone, this is Lakshya. In this video, we are going to see the problem number 2348 LeetCode, which is number of zero-filled subarrays. So what this problem states, given an integer array nums, return the number of subarrays filled with 0. A subarray is a contiguous non-empty sequence of elements within an array. For example, the example given here is nums 1300204. Here the number of subarrays we have to return. So there are four zeros in the set of twos, okay, in the two sets of two zeros, okay. So how many subarrays are there? It says there are four occurrences of single zero, set of subarray of single zero as a subarray. As we can see that 1, 2, 3 and 4. There are two occurrences of 0, 0 as a subarray. As we can see that one subarray is this, another subarray is this. So 1, 2, 3, 4, 5 and 6. So there are six subarrays of zeros. Similarly, in the another example, the number of subarrays. For firstly, we have three zeros, which have how many subarrays will be there in these three zeros? 1, 2, 3 of single zeros. If we count subarrays of length 2 having two zeros, there are 1 and 2, right? Uh, Sorry, this 1 and this 2, right? And how many subarrays are there of size 3 having three zeros in this 1? So 3 plus 2 plus 1, 6 plus how many subarrays are there in the size of 2? So 1, 2 and 3. So there are 6 plus 3 is 9. 5 occurrences of single zero, 1, 2, 3, 4, 5. 3 occurrences of two zeros, 1, 2, 3. And 1 occurrence of three zeros. Okay, so it becomes 9. In the another example, in the example 3, there are no zeros, so there is no subarray filled with zeros, so therefore we return 0. So let's first understand it in the whiteboard. So what is our goal? What is our goal? We have to find the subarrays given that we are given with an array of zeros, right? We are breaking the problem into smaller subproblems, right? So when n equals to 1 means when there is only one zero, how many sub arrays can be there? Of course, there will be only one subarray of one size. So the total subarrays in 1 0 is 1. Okay. How many subarrays are there in array of two zeros? Uh, let's use the highlighter. There is this 1 0, 1, 2. So there are two zeros, there are two subarrays of single zeros, and there is one whole subarray of two zeros. So there are a total of 2 plus 1, 3 subarrays. Okay. Now similarly, when n equals to 3, there are 3 zeros. So how many subarrays are there of single zeros? 1, sorry, 1, 2 and 3, right? There are three subarrays of zeros having of subarrays having single zero. How many subarrays are there of two zeros of length 2? 1 and then 2. Okay, so there are two subarrays of length 2 having two sub-zero subarray of two zeros. How many subarrays are there of three zeros? Only one, the whole subarray itself, right? So 3 plus 2 plus 1 is 6. Similarly, for 4, uh, there are 4 subarrays of single zeros, 1, 2, 3, 4. Then there are 3 subarrays of two size, two zeros, 1, then 2, then 3, right? There are two subarrays of size 3, three zeros. That is this one and this one, right? The subarray should be contiguous as mentioned in the question itself, the problem statement. And how many subarrays are there of 4 size? Okay, so there is only one subarray of 4 size of 4 zeros, which is 1. So 4 plus 3 plus 2 plus 1. When n was 4, when there were 4 zeros, the total of subarrays will become 10, which is 4 plus 3 plus 2 plus 1. Similarly, for 5, this will become 5 plus 4 plus 3 plus 2 plus 1, 5 subarrays of single zeros, 4 subarrays of 2 zeros, 3 subarrays of 3 zeros, 2 subarrays of 4 zeros, 1 subarray of 5 zeros. So can we see a pattern in this? We can see that when n was 1, there was only 1. When n was 2, we were starting from 2 and we were traversing till the 1 and we are adding the number in between. That is 2 plus 1. When n was 3, it was 3 plus 2 plus 1. When it was 4, it was 4 plus 3 plus 2 plus 1, and similarly for 5 it was 5 plus 4 plus 3 plus 2 plus 1, right? So we have to get some formula of deducing this, of getting this number of subarrays when we were given this n, right? So we will be deducing, we will be getting a formula or a relation in which we'll be putting this n value, and from that formula we will be getting this number, the number of subarrays having in the array having n zeros. So can I write this for can I write this sequence 5 plus 4 plus 3 plus 2 plus 1 as 1 plus 2 plus 3 plus 4 plus 5, right? There's no difference between this. We know that in addition a plus b is equals to b plus a. Order doesn't matter, right? So we can write this sequence in reverse order from 1 till the n. 1 plus 2 plus 3 plus 4 plus 5. Now, do we know any relation or formula to get the sum of nth term, right? Yes, we know that. Sn is equals to n by 2 into 2a plus n minus 1 into d. Now what is this formula? This formula is used to get the sum of n values starting from the first term a, difference between the any two consecutive numbers d. These are the parameters that should be given to us to get the sum of the nth term. So here we can see that the first term is always 1. We can see that if we write the sequence of any sequence in reverse order, it will always start with 1. So a will always be 2. Sorry, 1. A will always be 1. So a will always be 1. N can be a variable, right? N can vary. N can be 1, 2, 3, 4, 5, or it can be anything. So we will write n as it is. A as 1, 2 into 1 plus n minus 1, and d. What is the difference between any two consecutive elements? 1 plus 2, 2 minus 1 is 1. 3 minus 2 is 1. So we are incrementing by 1 only, right? So the d becomes 1. Further reducing this formula to get we are basically simplifying this, right? So n by 2 into 2 into 1, which is 2. N minus 1 into 1 is n minus 1. Further simplifying this, we get 2 minus 1, which is 1, plus 1, right? So n by 2 into n plus 1. So this is the formula that we will be using to get the sum of to get the number of subarrays given we have n zeros, an array of n zeros, right? So this is the final formula. Let's take an example. For example, this n equals to 5. I'm taking this same example, n equals to 5. When we were having 5 zeros, right? So let's put this n in the places of n. So 5, we put 5 in the place of n, 5 in the place of n. So it will become s of 5 equals to 5 by 2 into 5 plus 1. Now one important thing to note here is that this 5 by 2 is a real division. It is not an integer division. We know that in programming, division can be of different types, right? It could be an integer division or it could be a floating point division. For in this example, we would be only using a floating point. It is the real division. In integer division, we do not get the values after the decimal point. For example, if we were doing the integer division, we will be only getting this 2 and not this 2.5. But for this formula to work properly, for us to get the right answer, we would be only using this real division, not the integer division. So 5 by 2 becomes 2.5 and 5 plus 1 becomes 6. 6 into 2.5 is 15, and we can see that from here when we were having 5 zeros, an array of 5 zeros, we were getting 15 subarrays. So this formula is working and we will be using this formula, right? So let's take a look at the code. Okay, so let's look at the code. Uh, I'm using C++ for now, but you can use any of the programming language of your choice. So we can see that firstly it is expecting the answer returned to be in the form of long long. So let's maintain a variable known as answer of long data type and initialize it with 0, right? Then we will be taking another let's say n equals to 0. This is the same n which we were talking about here. The number of zeros that we are having currently, right? So this is initially 0. This means we have not processed any of the subarray of zeros. So let's start traversing in the array for int I equals to, starting from the 0th index till the nums dot size. Okay, and we are incrementing by 1 okay. Now say if my current element, for example here, if my current element is 0, I will be incrementing the n. So if nums of I is equals to 0, okay, what I will be doing, I will be incrementing this n. This indicates that this is we are doing this to get the current size of the subarray of zeros, right? uh, okay, so for example, yeah, we will understand it. Okay, else what we'll be doing, now if my current element is not 0, that means I have already processed a sub array of zeros. For example, here this is not 0, this is not 0, this is 0. We have incremented it the n by 1, then by one more 1, so n becomes 2. Here it is not 0, so else what we'll be doing, so we are using this formula. So answer plus equals to answer. In the answer we are adding this using this formula, which is n, my current n. How many zeros have I processed till now? We will divide it by 2.0, not just 2, because we are doing the real division. If we just divide it by 2, we will not be getting the right answer, right? Into what it was, n plus 1. Okay, let me zoom it out first. Okay, so yes, and now we have to reset the n to 0, so that we have to process the further subarrays, right? After processing this subarray, I have another subarray of zeros here, so I have to process that as well. So I have to count, this is a counter, right? I have named it as n, so we have to reset it every time we process one, the current subarray. So after this, what we'll be doing, we will be returning answer, right? We have already got the answer using this, right. Let's run this once to understand if this is working or not. Fine. Okay, wrong answer. Why? Because there is an edge case. For example, if we look at the example 2, if we carefully look in this for loop, what we are doing, we are processing the subarrays. But what happens when the subarray is also present, of subarray of zeros is also present at the last of the whole array nums? We have incremented the counter 1 by 1, so the at the last the value of n becomes 2, but we have not processed it. We have not added the calculation of this formula into the answer for n equals to 2 for this last part, because we have exited the loop. We have already processed the whole array. So what we have to do, we have to, at the last, we have to just again do this step for once, which is n by 2, so that it indicates if there is any value present in n again. so it will also get added to the final answer. Okay, let's try to run this. Okay, so all the it is all clear, right? Accepted. Let's submit it. Okay, so it is accepted, right? Uh, okay, so what is the time complexity of this? As we are just traversing the whole array once, every element once, so this is equals to big of n linear, where n is the where sorry where n is the size of nums vector. Okay, and what is the space complexity? This is constant because we are not using any extra space or data structure. We are just using these two variables, and this will not be counted as the extra space. So yes, this was the solution for this. Now if you are confused that how we got this formula and what are these calculations, you can just use a for loop starting from 1 to till the n, where n is inclusive. Let me show you that as well. Okay, so just maintain a temp variable of long because the answer is long and okay, temp equals to 0, right? Now for I equals to 1 to I less than equals to, because we are including this n and plus I, temp plus equals to, we are adding the I to n elements. We are adding all the numbers like this, right? What we were doing here, 1 plus 2 plus 3 plus 4 plus 5. So for loop starts from here and goes till here, adds all the numbers, and all the numbers, after all the numbers are got added, it will be added to the final answer plus equals to 10, right? Okay, and we have to do this step again at the last as we have done before. Let me select and copy this. Okay, little formatting issue. Let's resolve this first, and let's run this. Okay, there is some. Okay, got it. I guess what is that? N equals to 0 and let me first see this. What is happening here? 10 plus equals to I. Okay, sorry. I think we had forgot this int. Okay, I think it should work. On. Okay. Time limit got exceeded. This is strange. Okay, so I made the corrections. Actually, I forgot the int here as well. So I just put the int here. And now it is working fine. Let's see. Yes, it should work. Okay, so let's submit it as well. Yes, it is working completely fine. Okay. Now, what is the time complexity in this case? Uh, Now, if we see at one of the examples, like here, so after we get the n value n is 2, n equals to 2 from here, we run the loop from 1 to 2, okay, to the size of n, and then from here again 1 to 2. So in the worst case when every element is 0, right? Every element is 0 except the last one. We are going till the last one. We got the n value as size of nums array minus 1, okay, and in that case I will be traversing again from 1 till the size of array, size of nums minus 1, and that will become 2n, right? It is not n square, it will become 2n because we are traversing the whole array two times. Okay, we are not traversing the whole array for every element. We are just traversing, in the worst case, we are traversing it 2 times. Okay. For example, if we talk about this example, yeah, this. So five zeros are there, n will become 5. This loop will be exited, and this n will become 5, right? For this example, n will become 5. The loop got exited, and after this loop again runs from 1 to 5, and it got our answer. It gets our answer. So we are traversing the whole array 2 times, so it will become 2n. Okay. So I hope this solution, this video will help you. So if you like the video, please like the video. Do like the video and share it with your friends and subscribe the channel. See you next time. Goodbye.